morning, student. Today I am going to discuss about lecture number 6, that is about Ohm's law. After that I will discuss about EMF as well as terminal potential difference. Okay. Now I will start with my topic, that is Ohm's law. You know, electrical resistance I have discussed already in lecture number 4 or 5. I have no idea about that thing. So here electrical resistance means what? Electrical resistance is the net opposition offered by the conductor whenever the current flows through that circuit. Okay, that is called electrical resistance. So in electrical resistance, while we calculating, there is a potential difference across the two ends of the conductor when there is a current flowing through the circuit, so that we got the value like as potential difference per unit amount of current, which gives a quantity which represent a quantity, that quantity represent as a resistance. Okay, so in electrical resistance, you know that in case of every material has some resistance is there, but if we assume in case of ohmic conductor the resistance becomes constant, otherwise it not be a constant quantity, it is different for different material. And now I'll discuss about Ohm's law. What do you mean Ohm's law? It states that current passes through conductor when there is a potential difference across the two ends of the conductor. Under such given condition, like as temperature, pressure, as well as mechanical strain remains constant. Clear? So what do you mean by Ohm's law? It states that current passes through the conductor when there is a potential difference across the two ends of the conductor. That means if you assume this is the conductor is here, and now the conductor which is connected to a cell or battery, okay, it has two terminals. One is higher terminal, it is taken as a positive, other terminal is taken as negative. So there is a potential difference across the cell is here, that is represented as a V volt. That V volt can be assumed across the two ends of the conductor is given by V volt and 0. There is a difference between the two potential, that is V minus 0 is equal to V volt is 0. So whenever there is a potential difference across the two ends of the conductor, such that the potential difference is required to easily carry the current continuously, okay, through the circuit or that conductor. You know that thing, already I have discussed. That means what will happen? Here the electrons inside the conductor is there that also move opposite to that of what? External electric field. Clear? That's why there is a current which is drawn in the circuit and it moves continuously in a closed circuit. It is I. So at that time, what will be remains constant? That is temperature, pressure as well as mechanical strain remains constants. So Ohm's law states that the current passes through the conductor when there is a potential difference across the two ends of the conductor. Clear? This is the potential difference across the two ends of the conductor. Under such given condition, आमे किसी कंडीशन को नेले से कंडीशन रे कोन टेम्परेचर रिमेन्स कांस्टेंट रहबार अछि से जगह रे प्रेशर भी रिमेन्स कांस्टेंट रहबार अछि द्वितीय कथा मैकेनिकल स्ट्रेन रिमेन्स कांस्टेंट मैकेनिकल स्ट्रेन माने कोन स्ट्रेन मींस चेंज इन लेंथ okay that length of the conductor remains constant okay so there is no mechanical strain is there that means mechanical strain remains constant so from above definition we conclude that okay that means I directly proportional to del V. That means the current which is directly proportional to change of potential, or in other way, or the change of potential difference which is directly proportional to I. Okay, that means if you remove the proportionality del V which is equal to some constant quantity which is multiplied with that current, that constant quantity can be represented as resistance. So here R equal to resistance of given conductor. Okay, that R remains constant where the conductor obey Ohm's law. Otherwise, it could not be constant. It becomes vary from different material. Okay. Those substance which obey Ohm's law, that's why that substance is an ohmic conductor. At that case, the R remains constant. Okay, are you getting my point? Please note it. That's why if you assume that R, how to calculate R? R equal to del V by I. So, or we can represent V by I. So R equal to del V by I or V by I. So this is the formula of resistance equal to del V by I or V by I. Please note it. Then I will prove Ohm's law in scalar form as well as vector form. Scalar form of Ohm's law. We know the relation between current and drift velocity. We know the relation between current and drift velocity. So I equal to NEAVD. That means I equal to N means number of electron per unit volume, E means charge of electron, that A means area of conductor, and VD means drift velocity of electron. Clear? So we can say that I equal to Vna or NEAVD. Similarly, we know drift velocity is given by Vd equal to EV by ml into tau average or tau. Clear? If we put the value of Vd in that given equation, if we put the value in given equation 1, then I equal to NEA, Vd means EV by ml into tau. Clear? So I by V, that V is in right side, that moves in left side in denominator. So I by V equal to NEA. NEE means E square, A tau by ml. Now V by I equal to ml by Ne square A tau. Clear? So before I have discussed V by I means what? That means R. R equal to what? R equal to ml by Ne square A tau. Okay. Here M means mass of electron remains constant. L means length of conductor remains constant. N means number of electron per unit volume remains constant. E means charge of electron remains constant. Area of cross section of that given conductor also constant, and relaxation time becomes constant for a given particular temperature or pressure as well as mechanical strength. Okay. So all are remains constant. That's why resistance becomes constant. While in case of ohmic conductor, clear? Otherwise it could not be constant. Clear? For ohmic conductor, resistance becomes constant because all these quantities remains constant. Clear? Okay. So this is the scalar form of Ohm's law. That implies R equal to, we can say that M by Ne square tau into L by A. Here in above formula we can say that M is the mass of electron remains constant, N means number of electron per unit volume remains constant, E means charge of electron remains constant, tau is the relaxation time, it is also remains constant for a particular given temperature. Okay. So resistance, which is directly proportional to length of the conductor, and it also inversely proportional to area cross section. If we increase the length and decrease the area cross section, then resistance becomes vary. Clear? But its volume remains constant. Okay. So here we represent R equal to M by Ne square tau means rho, that is the nature of the material, into length of the conductor divided by area cross section. Clear? Please note it. It only depends upon temperature as well as nature of the material, that is called resistivity. But resistance depends upon nature of the material, length of the conductor as well as area cross section. Okay, that natural material remains constant. That's why resistance directly proportional to length of the conductor and inversely proportional to area cross section. Its volume remains constant. If you increase the length of the conductor, at the time area becomes decreases. If you increase the area cross section, then length of the conductor becomes decreases. So if one is increases, then other one is becomes decreases. Its volume remains constant. Please remember that thing. Clear? So this is called scalar form of Ohm's law. Please note it. Now I am going to discuss about vector forms of Ohm's law. Vector form of Ohm's law. So similar thing, we know I equal to NEA VD and VD equal to EV by ml into tau. So if you put the value VD in given equation 1, we put the value in of VD. If you put the value of VD in equation 1, then I equal to, what will happen? NEA EV by ml into tau. So I equal to ne square AV by ml into tau. V by L, that implies V by L equal to what will happen? I m divided by ne square A tau. Clear? V by L equal to I, sorry, this one is small I m by ne square A tau is 0. So here we know the relation between potential difference and electric field, that is E equal to minus dV by dr. Okay, E equal to minus dV by dr. This is the relation between electric field and potential difference. E equal to minus dV by dr equal to here. So E equal to gradient of dV by dr. So we can say that E equal to V by R. We can say that E equal to V by R, or we can represent in the form of R in terms of L. So V by L equal to E. So if you put the value V by L in the form of E, so that is here V by L equal to E equal to I m by ne square A tau. That implies E equal to m by ne square tau I by A is 0. So here E equal to m by ne square tau can be represented as what? Rho. And I by A they represent as J. Okay, J means what? Current density. Here J vector called current density. What is the current density? Current density means whenever if you consider this is the conductor, okay, this is the conductor. Suppose if you assume this is the small cross sectional area is here. Here inside the area the number of electrons which are floating, suppose this is the direction, that electrons which are floating inside the conductor. So the number of electrons which are flowing through a area, so it assume a current. The current drawn from a particular area, that is called current density. Current per unit area called current density. Clear? So current density is a vector quantity because area is a vector quantity. So current density is a vector quantity. Similarly, electric field also a vector quantity. So electric field equal to rho into J vector. Clear? That implies J vector equal to 1 by rho into E vector. Rho means what? What? That is resistivity of a material. What is by resistivity? Resistivity means whenever there is a current which is flow through the material, then it is opposed by the material. That is called resistivity. Okay. So resistivity depends upon nature of the material as well as depends upon temperature. We know that conductivity, already I have discussed in before class, conductivity is the reciprocal of resistivity. So conductivity means what? If you consider a substance or material, whenever there is a current which is passing through that material, okay, which represent conductivity. Conductivity means how much amount of electric current which becomes conduct by the material. That is called conductivity. That's why conductivity is the reciprocal of resistivity. So here we can say that 1 by rho can be defined in the form of sigma. Okay, so that is 1 by rho. Rho means resistivity and sigma means conductivity of the material. Clear? That's why we can represent J vector equal to sigma into E vector. So this is the vector form of Ohm's law. This is called vector form of Ohm's law. What? That is J vector equal to sigma into E vector. This is the vector form of Ohm's law. J equal to sigma E, where J is known as current density of the material, sigma is known as conductivity of the material, E means electric field which is applied externally due to potential difference across the two ends of the conductor. Okay, please note it. Now, if we plot a graph between voltage versus current, if we plot a graph between voltage versus current, this one, V along x-axis and I along y-axis, then the graph is shown, and that graph represented as a linear graph. Okay, that graph shows for ohmic conductor, those conductor which obey Ohm's law. That's why there is a linear graph is obtained between voltage versus current. That graph shows what? Linear graph. So that is V and that is I, or that is the change in potential is here. Clear? So there is a graph is here. That graph is linear graph. Linear. It is for ohmic conductor. Ohmic conductor. Okay. That means we know del V by I means what? Constant. That constant represent R. For non-ohmic conductor, if you plot a graph, voltage along x-axis, current along y-axis, the graph is like that. Graph is like that. After that, it becomes bent. So here in above graph, in a particular certain time, it becomes linear. After it becomes non-linear. So this is the linear graph. But there is some curve is here. Due to curve, that means that represent a non-linear graph. So it is obey for non-ohmic conductor. So that graph shows for non-ohmic conductor. Clear? This graph shows for non-ohmic conductor. In that case, R becomes varying. Okay. Similarly, for semiconductor, if you plot a graph V along x-axis, I along y-axis, okay, the graph is like that. This is for semiconductor. Clear? For semiconductor, graph becomes in that line. Okay. So that is V and this is also I. This is the third quadrant, this is the first quadrant. So it is in forward bias and it is in reverse bias. You know about that is in p-n junction diode is here. The graph shows p-n junction diode. So that p-n junction diode behaves as a semiconductor. That's present. A non-linear curve is there. The graph does not obey Ohm's law. Clear? Similarly, for gas, if you plot voltage along x-axis, current along y-axis, so the graph is like that. So at first it becomes linear, after that becomes irregular, again it decreases downward, after that again it becomes linear and moves in upward direction. So that graph shows for gas. It is also a non-ohmic conductor. It also obey in case of non-ohmic conductor, gas also called. And its resistance always always negative. Okay. In case of gas, resistance always negative. So that graph shows ohmic conductor as well as non-ohmic conductor. Okay. Ohmic conductor means what? In ohmic conductor, resistance always remains constant. But for non-ohmic conductor, resistance could not be constant. It becomes varying in different material. Okay. So this is all about graph for ohmic and non-ohmic conductor. Now I am going to discuss about EMF. EMF. EMF means electromotive force. Okay. Here, electromotive force is not a one type of force. It is a potential. Please remember that thing. Electromotive force is not a force. It is a potential. Clear? So what is the electromotive force? So here it is the maximum potential difference between two electrodes of a cell when there is no current is drawn. When there is no current is drawn. That means the circuit is in open circuit. The circuit is in open circuit. So it is the maximum potential between two electrodes of a cell when there is no current is drawn. That is, the circuit is in open circuit. That means what? If you consider a beaker, this is the beaker. Okay, this is the beaker. Here, inside beaker, there are many amount of electrolyte solutions are there. This is the electrolyte solutions. Now, if you consider two electrodes, they are dipping inside the electrodes. So, the 2 points of the electrodes, they are connected by the voltmeter or potentiometer. Okay, they are connected by the potentiometer that measure the maximum potential. Okay, that measure maximum potential. That potential can be represented as EMF. तार तो कौन जदि हम गुटे बेकर नबा ता भितर कौन रखिबा गुटे इलेक्ट्रोलाइट सॉल्यूशन रखिबा इलेक्ट्रोलाइट सॉल्यूशन नबा ओके आ कौन नबा दीटा इलेक्ट्रोड नबा से दीटा इलेक्ट्रोड रो प्रांत को हम जदि गुटे ई कोन बेट सॉरी गुटे पोटेंशियोमीटर द्वारा कनेक्शन दबा ताहाले पोटेंशियोमीटर काम कोन जे एक्यूरेटली मेजर करिवो कोन पोटेंशियल डिफरेंस हला औ ए दिटा सर्किट को ए दिटा इलेक्ट्रोड को हमें कोनोसी जो कोनोसी ले एक्सटर्नल रेजिस्टेंस को हमें कनेक्शन देई नथिबा तार तो कोनोसी गुटे सर्किट भी हमें कनेक्शन देई नथिबा ताहाले ये जो पोटेंशियल डिफरेंस मेजर करिवो ताकू कहिबा EMF. So EMF means it is the maximum potential difference between two electrodes of a cell. This is the cell. When there is no current is drawn. Tartha आदि की कौन होनी current pass होनी. That is the circuit is in open circuit. तो ये circuit टा कौन अच्छी open circuit अच्छी. तारथा ये cell को कौन सी circuit द्वारा connection है नहीं. तारथा ये कौन हिला open circuit हिची. Okay. तो सेथिरे जो अमाउंट रो पोटेंशियल पाइबा से पोटेंशियल को हमें कहबा इलेक्ट्रोमोटिव फोर्स बोली कहबा क्लियर इलेक्ट्रोमोटिव फोर्स इज ए potential it is not a force clear that electromotive force which is generated from the cell or battery due to okay mechanism of battery that EMF which will be found from the battery due to some mechanism which are obtained from the cell clear it is the potential difference it is not a force तो सेल रो काम कोन सेल रो काम होला चार्ज को जनरेट करि बनी क्रिएट करि परियोनी चार्ज ये कोन करि परिबो इजीली which energy देकी चार्ज को कोन करिवो फ्लो करिवो in order to flow the charges it could not be generate the charge okay so cell always flow the charges externally clear okay so that is all about EMF now I'm going to terminal potential difference what is by terminal potential difference जदि ए सेल को एटा होची टोटल सेल टा ए सेल को जदि हमें गुडे एक्सटर्नल सर्किट द्वारा कनेक्शन दबा तार तो गुडे रेजिस्टर को नेकी आरो दीटा प्रांतर जदि हमें कनेक्शन दे दबा इन दैट रीजन so this is the cell here two electrodes are there that two electrodes are connected to that external resistor okay and inside the cell inside the beaker there are electrolytes are there this is the electrolytes and this is the two electrodes and this is the external resistance external resistance it is donated by capital R okay ताहले आको हमें कहिबा सर्किट बोली कहिबा एडा होची सेल ए टोटल को हमें कहिबा कोन बोली कहिबा सेल बोली कहिबा कोन कहिबा एडा को सेल बोली कहिबा एती को ताहले आको कोन कहिबा एक्सटर्नल वायर बोली कहिबा का कनेक्शन छी गुड रेजिस्टर तार तो ये गुडे सर्किट तार तो ए जो प्रांत को हमें कोन करिबा एबे गुडे वोल्ट मीटर द्वारा जदी कनेक्शन दबा V द्वारा ताहले ये जो पोटेंशियल को सूचेइबो से पोटेंशियल को कहिबा terminal potential what do you mean by terminal potential it is the maximum potential which is obtained by the cell when the cell connected to that given circuit that means the circuit is in closed in nature okay so what do you mean by terminal potential here it is the maximum potential difference between two electrodes between two electrodes of a cell when there is a current passes through an external resistance in a closed circuit. Clear? So it is the maximum potential difference between two electrodes of a cell when there is a current passes through an external resistance. This is the external resistance. Passes through an external resistance. Okay? In a closed circuit. This is the closed circuit. Okay? So that is called terminal potential. If the circuit is in open, then we have assumed a potential difference. That potential difference behaves as a EMF. If we connect external resistance to that given cell, then there is a potential difference across the two electrode. That potential difference represent as a terminal potential difference. So from above consideration, we have notified that what? EMF equal to what? Potential difference across the two ends of the conductor, that represents as a terminal potential difference, plus there is a current flowing through the circuit and it has some internal resistance. What is by internal resistance? When there is a current which is flowing inside the circuit, due to electrolytes and due to electrodes, there is a resistance becomes produced inside the cell. That resistance behaves as the internal resistance of the cell. Okay. So internal resistance is the resistance which is generated from electrolyte as well as electrodes. Okay. Now I am going to discuss about internal resistance. Please note it. Internal resistance. It is denoted by small r. So what is by internal resistance? It is the resistance offered by electrodes as electrolyte of a cell when there is a current pass through it. So it is a resistance offered by electrode and electrolytes. So if you assume this is the cell, here inside cell the electrolytes are present and two electrodes are there. When there is a current pass through that external resistance and it also pass through inside the electrolyte. So due to internal resistance, that internal resistance affect the electric currents. Here there is an internal resistance becomes produced inside the cell. That internal resistance which will be done due to electrolyte as well as electrodes inside the cell, that is called internal resistance. So it is the resistance offered by the electrodes and electrolytes of a cell when there is a current pass through it. That means जदि ए सेल को हमें कौन करूचे सिंबॉलिकली जतळ एज्यूम करूचे त हमें कोई हिसाब दोचे एटा होस तमरो सेल, एटा होस तमरो हायर पोटेंशियल, एटा होस तमरो लोअर पोटेंशियल. दिस आर द टू इलेक्ट्रोड्स और आको हमें टोटली कहिबा कोन ओरे सेल बोली कहिबा. ए सेल रो कोन अछि इंटरनल रेजिस्टेंस भी अछि. दिस इज द इंटरनल रेजिस्टेंस. इट इज डोनेटेड बाय आर. आको हम ए हिसाब डिफाइन कर परिबा किंबा हम ए हिसाब भी डिफाइन कर परिबा. एडी भी लगे देले भी हबो इंटरनल रेजिस्टेंस, किंतु हम आको कोन करिया छी ब्लॉकेज करिवार अछि. ओके. So that is small r and that is E or B, that is E. Clear? Okay. जतबेले की का देख जाउची उडे एक्सटर्नल रेजिस्टेंस देकी करंट जतबेले ड्रॉ हबो. सबल मन रखो EMF रो जदि EMF कौन कला चार्ज को सेंड कला ता तो ये कौन कला चार्ज सेंड होला मींस करंट जनरेट होला दैट करंट passes in the direction current always moves from higher potential to lower potential externally but internally it moves from lower potential to higher potential okay mone rakho cell provide energy so that due to energy the electrons are moving in externally inside the circuits okay that's why there is a current which is moving inside the circuits but that current which is moving from externally from higher potential to lower potential of the given cell and it becomes moving from inside the cell from lower potential to higher potential so there is a resistance is obtained inside this cell that resistance behaves as a internal resistance which is found from electrolyte as well as electrodes of the cell okay this is the definition of internal resistance. Now, here, internal resistance depends upon internal resistance depends upon one nature of the electrodes, nature of and electrolyte solution. So first one is nature of the electrode. Electrode देखो को material रे तैयारी चले ता ऊपर डिपेंड करिवो आ इलेक्ट्रोलाइट सॉल्यूशन ऊपर डिपेंड करिवो से H2SO4 ZnSO4 ए हिसाब रे डिपेंड करिवो को प्रकार सॉल्यूशन हमें ऐड करछे गोटे सेल रे ओके ता ऊपर डिपेंड करिवो हला ता तो इंटरनल रेजिस्टेंस डिपेंड्स अपॉन नेचर ऑफ द इलेक्ट्रोड एज वेल एज इलेक्ट्रोलाइट ऑफ द सॉल्यूशन. Second thing is it depends upon temperature of the electrodes as well as electrolyte solution. Second thing is temperature of the electrodes as well as electrolyte solution. Third one is it depends upon distance between the two electrodes. Distance between two electrodes. Clear? That means this is the two electrodes are there. While there is a distance between them is very large, at that case the internal resistance becomes what? Increases or decreases? The internal resistance becomes increases. So this is the important points. Fourth one is it depends upon area of electrodes. Area of electrodes. When they are immersed in electrolyte solution. तार जेतला में गुटे इलेक्ट्रोलाइट सॉल्यूशन भितर गुटे दीटा इलेक्ट्रोड को डिप करिबा तार एरिया ऊपर भी डिपेंड करिवो कि इंटरनल रेजिस्टेंस. सो दिस आर द सेवरल कंडीशन वेयर इंटरनल रेजिस्टेंस डिपेंड्स अपॉन दैट फैक्टर्स. ओके प्लीज नोट इट. Difference between EMF and potential difference. EMF potential difference. Terminal potential difference. Potential difference. So this is so first one is it is the maximum potential difference between two electrodes when there is no current is there. No current is there. Here, terminal potential difference means it is the maximum potential difference between two electrodes when there is a current flow through the external resistance. Of the circuit. Clear? Next point is EMF becomes calculated when the circuit is in open circuit. Is an open circuit. That like that. This is the battery. Okay. So this is the open circuit. There is no external resistance which is connected between the two end of the wire of the cell. So this is here. This is the internal resistance R is here. That becomes calculated and that is connected to a voltmeter or potentiometer. Okay. This is potentiometer. Here it is obtained, that is EMF. Okay. Similarly, terminal potential difference becomes calculated when the circuit is in closed is a closed circuit. Closed circuit means what? So this is the cell. It has plus and minus. Here, that two end of the cell, they are connected by an external resistance, that is R. Here we have joined a voltmeter so that voltmeter measure the potential, and that potential becomes quite minimum as compared to EMF. Okay, that it can be represented as a V. Okay, V represent terminal potential. Here, so this is the complete circuit, this is the open circuit, and this one is the closed circuit. Okay, so here external resistance is here, there is no external resistance is here. So next point is it does not depends upon external resistance. Clear? It depends upon external resistance. Clear? So it does not depend on external resistance. Here that circuit is in open circuit because there is no connection is here. So that it not be a what complete circuit. Here that resistor is here. That resistor which is connected to the two end of the wire of the battery or the cell. Okay. cell. That's why it is a closed circuit. That's why there is a current which moves inside it. That is the I current. There is no current is here. No current. Please note it. Then I will erase. Here next point is E equal to V plus IR. That represents V equal to E minus IR. What? That means V. That is V equal to, that is the total EMF E which is provided by the cell, and there is a current flowing through the circuit. Due to internal resistance, the current is moving from lower potential to higher potential. Due to external resistance, there is a potential drop across here. That potential difference is known as terminal potential difference, and that potential difference always less than that of EMF of the cell. Okay, because there is a few amount of current becomes drops. Okay, so this is the formula of potential difference equal to E minus IR. That means EMF of the cell minus total current flowing through the circuit into internal resistance of the cell. Okay, here E equal to V plus IR. V means terminal potential difference plus current flowing through the circuit into internal resistance of the cell, which gives electromotive force. That means here in both of the formula we notified that EMF of the cell contain maximum potential difference, but terminal potential difference which makes potential difference quite less than that of the EMF of the cell. EMF contain maximum potential difference. Here terminal potential difference creates potential difference quite less than that of EMF of the cell. Clear? So EMF contain maximum potential difference. Okay. Here terminal potential difference create potential difference quite less than that of EMF of the cell. कौन ए टर्मिनल पोटेंशियल जहां भी पाइबा से काठर छोट रहबो EMF of the cell रो छोट रहबो. Okay, therefore EMF is the cause, terminal potential difference is the effect. Okay, तारथ कौन EMF is the cause. तारथ देखिबा एटा देखो टर्मिनल पोटेंशियल डिफरेंस इज द इफेक्ट. दैट मींस जदि तमरो EMF न थांता ताहले हमें कोड पाइ परियन कोन पाइ परियनी टर्मिनल पोटेंशियल डिफरेंस पाइ परियनी. तो टर्मिनल पोटेंशियल डिफरेंस इज द इफेक्ट. ए जो इफेक्ट का जो होउची EMF द्वारा होउची. तेनो EMF टा कोन द कारण दैट इज द कॉज. EMF is the cause, terminal potential difference is the effect. Clear? Okay, so this is current I is here, and there is a potential difference between them, between the across the two end of the conductor, and this is the EMF of the cell. So here V equal to E minus I into R, internal resistance of the cell. Because inside the cell there is a resistance is here. That resistance is called internal resistance of this cell. Due to internal resistance, there is a current which passes through that cell from lower potential to higher potential. Okay, and that potential becomes gradually decreases due to internal resistance. Therefore, total EMF of the cell equal to V plus IR in EMF, and terminal potential in case of terminal potential difference V equal to E minus IR. Okay. Next point is it becomes measured by potentiometric form. Potentiometry. It measured by voltmeter. Okay. So what is my potentiometric? What is my voltmeter? I have discussed at a 4 lectures or 3 lectures. Okay. Potentiometer means it measures accurately. It measures accurately potential. Okay. It measures potential not accurately. It nearly equal to. Okay. So EMF of the cell measured by potentiometric and voltmeter, terminal potential difference measured by the voltmeter. Clear? That represent potentiometer. V is here. Both are donated by B symbol. Okay. Please note it. This is the all basic difference between EMF and potential difference. Okay. Clear? This is voltmeter. Now internal resistance. Internal resistance. It is denoted by symbol small r, not capital R. Okay. So what is my internal resistance? Internal resistance is a resistance which is generated due to electrode as well as electrolyte whenever the current pass through the cell. That means, again I repeat that thing, internal resistance of a cell is defined as it is the resistance offered by electrodes and electrolytes of the cell when there is a current flow through it. Okay. So here this is the diagram while we calculating internal resistance of the cell. So that is the cell here inside the cell there is a internal resistance is here and two end of the cell connected to an external resistance by wire. So that is the external resistance is here. Okay. And that cell containing EMF E. Okay. And there is a potential difference across the two cells is here. And that potential difference calculated by the voltmeter. And that is known as terminal potential. Because there is a external resistance is here and that cell connected to that external resistance there is a current is drawn in a given circuit and that current is given as I. Okay. So internal resistance means, again I repeat that definition, it is defined as the resistance offered by electrodes as well as electrolytic solution of the cell when there is a current flow through the cell. Clear? It is defined as the resistance offered by the electrolytes as well as electrodes of the cell when there is a current flow through the cell. That means from above formula we know terminal potential difference equal to EMF of the cell minus total current flowing through the cell into internal resistance of the cell. This is the formula of terminal potential difference. So V represent as a terminal potential difference, E represent as a EMF, I represent as a current, R represent as a internal resistance. Clear? So V equal to what? E minus IR. So V equal to V minus E equal to what? R minus I into R. That implies minus taken in left side. So E minus V equal to IR. That implies R equal to E minus V by I. Clear? R equal to what? E minus V by I. Okay. E minus V by I is here. So again, we know from Ohm's law, V equal to what? I into R. I into not small r, that is the capital R. That means if you assume that is a complete circuit, that is a closed circuit, and that circuit behaves as that circuit connected to a conductor whose resistance is R, capital R. Okay, so that's why it obey Ohm's law. According to Ohm's law, V equal to IR. That implies I equal to what? V by R is here. Okay, V by R is here. So if we put the value, if we put the value of I in equation 1, then R equal to E minus V divided by V by R. That implies small r equal to R into that R which is going to numerator, R into E minus V by V. That implies R equal to R into E by V minus 1. So this is the formula of internal resistance of the cell, which is equal to small r equal to R external resistance into EMF of the cell divided by terminal potential difference minus 1. So this is all about internal resistance of the cell. In another way, you can define the formula of internal resistance here. Here another formula we can define from that given equation. Here V equal to what? E minus IR is here. V means what? That is from Ohm's law. V can be defined as I into capital R is here. So E minus IR is here. That implies what? I into R plus I into R equal to E is here. That implies I taken in common, R plus R equal to E is here. Okay, that implies R plus R equal to E by I. That implies small r equal to E by I minus R is here. This is the another formula we can define internal resistance equal to E by I minus R. Okay, this is the first formula and this is the second formula. Please note it. So please note it. Important things are there. We know the formula V equal to E minus IR. If the circuit is in closed nature, then the formula is there, that is known as V equal to E minus R. V equal to E minus IR is here. Okay. If there is no external resistance is here, that's why there is no current flowing through the circuit. If there is no external resistance is here, that's why there is no current flowing through the circuit. So V equal to E minus I is 0 into R. That means V equal to E. Therefore, EMF of the cell is equal to therefore terminal potential difference is equal to EMF of the cell when the circuit is an open circuit. Okay, at that case total terminal potential difference which is equal to applied EMF, and that has to be done when internal resistance becomes 0. So V equal to E means there is no internal resistance here and the circuit is an open circuit. At that case V equal to E is here. So terminal potential difference is equal to EMF of the cell when the circuit is in open circuit. Next point is when the cells are charged, at that case EMF of the cell always less than that of terminal potential difference of that cell. When cells are charged, then EMF of the cell less than that of terminal potential difference. That means E less than V. Clear? When cells are connected to that external circuit, then when cells are connected to that external circuit, at that case EMF of the cell greater than that of terminal potential difference of the external circuit. When cells are connected to that external circuit, at that case EMF of the cell greater than that of terminal potential difference. When cells are charged, at that case EMF of the cell less than that of terminal potential difference. So this is the very important notes, please note it. Clear? If any doubt, then ask me. Okay, please like, share my video. Thank you to all. Bye bye.